Okay, hello. I hope you doing great. So today's lesson we will be focusing on electricity. It's still Boss Move Academy, Mr. Kwabe. Okay, so without any waste of time, I have one of the question I took from September 2022. It was last year question, which is a preparatory. Okay, so the question comes like this. It says a battery is connected to two identical resistors. Now, these resistors are identical. Now, in two separate experiments as shown below. I hope you can see. Okay, I hope you can see my experiment one. Sorry about that. And I hope you can see my experiment two, the connection. Okay, so now, but the coolest thing is these batteries are the same, which means the EMF is the same, and the internal resistance of these batteries are the same. Nice. Okay, now they said the internal resistance and EMF of the battery are unknown. They're telling us we don't know the EMF, we don't know the internal resistance. Okay, it's cool. Now, the EMF, the ammeter and voltmeter reading in both experiments are shown in a table below. Sorry about the sound, the background noise, okay? Now, it comes like this one. Now, these are the reading, which means the ammeter, it reads 6.13, the voltmeter 18.40 in this experiment. Experiment 2, ammeter, 1.78, the voltmeter, 20.58. I hope you can see that. Okay, comes the first question. Let's try to see the first question. Comes like 2 marks. Define the term EMF. So simple. Okay, I wrote this. I tried to write this down for you. I wrote it. It's over here. So now the EMF is the maximum. The maximum energy. Okay, provided by a battery per unit charge passing through it. So that is an EMF. If you need to take some notes, please try to pause the video and write the definition down. Okay, now I want to go to the next question. Okay, thank you. Okay, what does the next question say? So now the next question comes like this. They said here, calculate the EMF of the battery. Look at the marks. 5 marks. Five marks. That is nothing. Okay, so how are you going to do that? When you check the diagrams, as I say, the EMF for both batteries are the same, and the internal resistance are the same because it's the same battery. Okay, so now what you're going to do, when you remember the formulas, I'm going to take this marker. Okay, it says the EMF equals to I, and therefore it's R plus R, or you can put this still the same thing. And the EMF is equal to I times R. This R is for external, okay, which means it's so your V external. Why? Because V is equal to I R. So which means this time this is going to get the external voltage plus your V internal. Okay, so now let's go back to something. Now we need to create two equations. Okay, how are we going to do that? We're going to create one for experiment 1 because we already have these external voltage when the circuits are operating. You're going to do it like this. You're going to create two equations. So you're going to write this down. When you check here, EMF equals to this times this is going to give you this one, V external, okay? V external plus your I. This time this is going to be IR. Now, as for the first part, for the other one, I'm going to use a different marker. Let's try to get it. I'm going to write this using this red marker. It's EMF equals to V external plus your IR. Okay, now I'm going to create two equations. EMF is the same. Internal resistance is also the same. So now here, it's going to be what? It's going to be, when you check the diagram, checking the diagram, now the ammeter reading is 6.13 on experiment 1, and the external resistance is what? Is 18.40, which means EMF equals to what? 18.40 plus the current 6.13, then R. Okay, then you're gonna go to the other one. Same thing, gonna do the same thing. EMF equals to external is 20, 0.58 plus your current is 1.78 R. Cause why? It's because the current is the same inside the battery and outside the battery. Okay, so then what is your next step? All you need to do, the EMF is the same and EMF is the same. You're going to equate them, which means, what that means? It simply means that if these are the same, which means this one are also the same. I hope you understand that. So you're going to equate them. We're going to say EMR, which means, so you're going to say this one 18.40 plus 6.13R is equal to this one, because these are the same. These are EMF. 20.58 plus 1.78R. You're going to take this to the other side, it's going to be negative. Take this to the other side, it's going to be negative. Then you're going to have 6.13R minus 1.78R is equal to 20.58 to the other side minus 18.40. So when you say this minus this, you're going to get 4.35R equals to this minus this is going to give you 2.18. Then you divide by this, divide by 4.35, divide by 4.35. You're going to get that you R. Your internal resistance is going to be 0.5011, which is approximately 0.5. Okay, 0.5 ohms. Okay, so now you have your internal. Now you know your internal, but we are looking for what? For an EMF. I'm going to write this over here. I'm going to write this over here. I'm going to write this over here. So how are you going to get your internal? Simple. Take one equation you created. EMF equals to 18.40 plus 6.13R. Okay, equals to, it's going to be 18.40 plus 6.13. Now you know internal resistance. I'm going to write this one. It's 0.5011. You're going to get that your EMF is going to be what? It's going to be 21.47 volts. Now that is the EMF they are looking for. I hope you can see. That was simple, okay? So if you want to take some notes, try to pause the video. I want to go to the next question. Here comes the next question. It says, calculate the resistance R of R. What's the resistance of R in R? Okay. I hope that will be simple. At least I will erase this part so that I can do the next question. Okay, if you haven't, tried to pause the video and you take some notes. Okay, so the next question, it comes like this. I'm going to do this in two ways. Okay, before I do it, I want to explain something. These two readings are external voltage because this voltmeter is parallel to this resistance. This voltmeter is also parallel to this resistance. So these are your external voltage. So if you say R equal to V over I, you will be calculating the external resistance. I'm going to start doing with the first one and also do it with the second one. So if you use experiment 1, it's going to be R is equal to V over I. So your voltage is 18.40. 18.40. Okay, it's 18.40, and then your current over here is 6.13. It's 6.13. 6.13. You're gonna find that the total external, because I'm using a total current and also the total external voltage equals to what? You should get 3.00 something, which is the same as 3 ohms. 3 ohms, which means when you add this, if you add these two resistance, you should get 3 ohms. Then you're going to start doing. Since there are two resistance, I'm going to keep it simple. What I'll simply say, I'll say my R torch is equal to R1 times R2 over R1 plus R2. This would be my R1, this would be my R2, okay? Then equals to, my R is going to be R, my R1 is R times R over, this one is R plus R, it's R plus R. This will give you R squared over to R. I hope you can see that, right? Then this will cancel this. Then you'll be left with what? You'll be left with, hope you can see. I'm going to continue over here. You'll be left with R third is equal to R over 2. Okay, since now you have calculated the total resistance in experiment 1, that it should be 3 ohms, which means here you're going to write what? 3, which means equals to R over 2. Now 3 times 2 is going to give you what? 6, which means resistor R is equal to 6 ohms. Now this is the first way. If you want to do it like this, you're going to get 6 ohms. But if you are using experiment number 2, it will be easy, because if you calculate the total resistance, you're going to divide by 2. You're going to get resistance in each a resistor. Okay, let's do the second one. So if you're working out with the second one, okay, if you haven't understand, please try to pause or re-watch the video. Okay, let's do the second one. Okay, I'm erase this part over here. Sorry about that. Okay, thank you. Okay, so now the second one, the reading is 20. Okay, I'm going to say R equals to V over I, was the voltage reading is 20, 58 over the current, it's 1,78. So when you use this, you're going to get that the total resistance for external circuit, it should be 11.56 ohms, which means for this part, when you add the 2, you should get 11.56. Then since they are in series, current, they are using the same current, which means what you need to do is to take this and divide by 2. 11.56 divided by 2 is going to give you 5.78 ohms. Now this is also a correct answer, which is the same as 6 ohms. I hope you understand that. Thank you, man. Thank you. Okay, now let's go to the next question. Okay, then the next question comes like this. 8.1.4. One of the resistors in experiment 1 is now disconnected. They are now disconnecting something. Maybe they are disconnecting this one, which means now when you disconnect this, we'll be left with only 1. Now let me tell you something. Once you decrease the numbers of resistors in a parallel connection, it increases the total resistance. Again, once you decrease the number of resistance in a parallel circuit, you are increasing what? The total resistance. So which means in this circuit, the total resistance will what? Will increase. So if you remember Ohm's law, it says R equals to V over I, or I equal to V over R, which means now this is increasing. What will happen to this? It should decrease. Okay, now the question says, one of the resist experiment 1 is now disconnected. How would this affect the power dissipated in a battery? How would this affect the power dissipated or the energy lost per second in a battery? Will it increase, decrease, or remain the same? What you thinking? Increase, decrease? Okay, let's try to check something. Because they say it here, explain by making reference to a suitable formula for power. Okay, so there's something I want us to remember. Okay, now we know that, which means the first thing, once you remove the total resistance, do what? Increase. Okay, it increases. Understand? So when it increases, there is a formula that I want to write down. You still remember the formula which says P equals to V squared over R. Where this comes from, this actually comes, it's actually, since we know the formula P equals to VI, so instead of V, since we know that V is equal to I, R, okay? So what, sorry about that, it's a mistake. Since we know that I equal to V over R, so instead of putting I, we can simply put what? V and then over R. So when you multiply these two, you're going to get that it's equal to V squared over R. So this formula, they've combined two formulas. Okay, now it's V squared over R. Okay, now this is increasing. Then what should happen to this? This should decrease. So which means the answer here it should what? It should decrease. Okay, that is the answer. The reason, the first thing you can say, when you remove one of the resistor over here, the total resistance will increase. Since it's increasing according to this formula, when you increase the total resistance, the power, then it should decrease, which means when you're removing a battery, the energy that will be lost per second will then decrease. That was a straightforward question. Okay, let's go to the last question. It comes like this. It says, a current of 4.4 amps, okay, a current, I hope you can see, sorry about that, a current of 4.4 amps passes through an oven, okay, for those who like to do noodles, you know, noodles, you know, okay, so, but there is a current passing through an oven of a resistance 50 ohms, which means this oven have a resistance of 50 ohms, and calculates the cost, okay, consumed by an oven in 6 hours if the price of electricity is R1.69 per unit, which means per kilowatt hour or per unit. Okay. Now, before we answer this question, I want to write this formula down for you for a cost. So to calculate a cost is equals to the power in what? In kilowatts times your time. In what? In hours. Okay? And then times your what? Your cost per unit. Okay, so now we are given in this part, which means what do we have? We have a current, and we have what? And we also have the resistance, which means to get our power, you will simply say, it's so simple. Since we know that power, I'm going to write this formula over here, power is equals to I squared R. I hope you remember this formula over here, which means here, what we normally say, you're going to say I squared R. Okay, since it should be in kilowatts, you're going to divide by 1,000. We are moving from watts to kilowatts, you divide by 1,000 times. They told us over here, this thing will be on, they said here, it will be by oven 6 hours. Now, which means this thing will be working for 6 hours, which means times 6. Okay, because it's in hours, times the cost per unit here. What's the cost per unit? They told us that the cost per unit is 1.69, which means it's R1.69. Okay, so when you do your calculations, if you punch all this in your calculator, you should get that the cost because when you punch this, it should give you write this correctly, sorry about that. It should be 0.968, and therefore you're going to say times 6 times R1.69, then the cost, it should be R9.81 which is the same as what is R9.82. Now that's the final. I hope you understand. And once again, thanks for staying with me. We finally finished the question. Just 17 marks this question. Thanks for your time. If you have any question, feel free to email me, or you can text me on the cell phone number 071-276-80772. Thanks for your time. It's your BMA tutor. Thanks for your time. See you next time. Sure.